Okay, so in the last part, we will try to make a little bit more advanced stuff. Maybe not extremely advanced, but we will try to make something um, yeah, at least curved and with three-dimensional models. So let's make it step by step to learn how we can operate on the first curves, then how we can operate on the solid geometry in Python. So let's go to the Python. And this time what I want to do, I want to create a dome. So similar thing what we have been practicing in the course, but yeah, since the Python it's a little bit independent part, so I will try to explain it in the step by step. So first let's create a grid of points. This time I don't want to just have I just want to create 9 points. From those 9 points, 3 points in the middle will have the possibility to control the height of the structure. So I will create 3 inputs. Those will be 3 heights. So number slider. Let's make it from maybe 1, or it can be from 0 till 12, and the step can be 12. So I will call it height 1. Control Z, Control V, Control V, and we got it. So height 2 and height 3. Nice. Connecting. And now we have to create 3 points or 9 points. 3 points in the sides will be on the 0 level, and the 3 points will be changing. Okay, so how to do it? Let's try to make it very simple on the beginning point by coordinates. Let's say that I would like to have it on the 20 or 40 meters span. So I will start with 0, 0, 0. Then I will just copy it. And then 0.2, or I will make it like this: 1, 2, 3, 2, 2, 2, 1, 2, 3, 3, 3, 3, 1, 2, 3. So 10, 20, sorry, 20, 40 we will make. And this one should be maybe 30, and this should be 60. And then the heights. Let's say that height 1 will be input 0, height 2 will be input 1, and height 3 will be input 3. And then nothing more than this, H1, H2, H3. Okay, so we have it. Now we have to collect those data. So I will type PTS1, a little bit of the writing, but it is what it is. PTS2, of course I make a mistake, 1, 3, P21, P22, P23, and then PTS3 equal to P31, P32, P33. Nice, up and running, and I will maybe make a collection of the points at the end. So PTS, it's just a combination of my PTS1, PTS2, PTS3. I really don't like this part of the coding, but let's see. Some small mistake, but again, line 12. H3 in, of course, 2. So nice. Okay, we have my points. So this is the grid of points. We see that the height of the middle ones can change. So let's try. Nice. So now I would like to create the curves. So let's try with the curves. So generating curves. And then what kind of the curve we can create? Curve by, let's see, by parameters, but then maybe we will type NURBS curve by points. Let's use this one. And then PTS1 will be my first NURBS curve. So, and curve 1. I'll just copy it and paste 2 times. I would like to have 3 of them. And of course, this is PTS2, PTS3. And I would like to take it out, so I want to create NURBS curves. NURBS curve 1, NURBS curve 2, and NURBS curve 3. Nice, some mistake. NURBS, I already see it even without checking the code, and then, or I will try to keep all the inputs, so I will just add it into the list. Let's try. Okay, so I'll just try to make it in such a way that it will be possible to observe everything. Okay, so you see that elements are controlling the height of the geometry. So the last thing which we need to create is to, for example, create a surface. So creating surface. Okay, what kind of the surface we can create? Let's try surface by loft, for example. And then let's see, and curves. Let's see, it should be working. So I'll type SRF. And I will also type here SRF. So I have a surface. When I am changing those inputs, I can make it in a different shape. Surface by loft we already talked about in the previous weeks or days, so I will not focus on it so much. What next? I would like to create a point on the surface. So let's see what we can do. I will type surface. And we have something here, let's see, point at parameter. Very nice. So I would like to use this one. And let's say that I would like to have it from the point at parameter 0, 0. And I would say SPT, so surface point. And this part of the code I will name creating surface points. Okay, we have some issue here. Let's take a look. Line 44, so exactly here we have a problem that we have the integer. Let's see if let's type here surface. Autodesk surface dot point at parameter. Okay, yeah, yeah, that's sorry. If I will, instead of the surface, which is generally some kind of the surface, I have to put my surface SRF. So sorry for a mistake, but also it will explain you something. I could use surface. I think if I will put here also a surface, then maybe it will work. Yeah, then it's also working. But you can always reference to the surface in this way. So both of them should be working. So 0, 0. And now we need to create some kind of the grid on my surface. So let's say that I would like to have the possibility to control how many elements I have on my surface. So I will create 2 extra inputs, and I will create here the input slider. Sorry. So I will go for the number slider, or integer slider, in fact, we can use. And say that I would like to have from 2 to, I don't know, maybe 25 will be enough. Okay, so then number of points in X direction. I will accept it. And the second one, number of points in Y direction. Okay, so this should control how many points I have in my pointed parameter. So now how I can create this number of points in the X and Y direction. Let's maybe make here a pause, and from now on I will work on my first definition, first method. So I need a method which will be creating a specific number of points from the 0 to 1. Okay, so we want to create a list of elements, so for a list of the points. So the example, what I want to do, I would like to have a list of params, or just params, I will call it params X. And I would like to have something like this: 0, 0, 0, 1, 0, 2, 0, 3, till 1.0. Here, this is not the design script tag, so I cannot use like 2 dots and say 0, 0 to 1, 0. It will not create me a list. So I would like to create my own definition. So let's go to the front of my code, and I will say my functions here. And I would like to have first my definition. So make parameters. How many? And then how many? Yeah, that's the good question. I would like them given by my input. So for example, if it's 2, then I should, for example, make parameter param, or I would call it a step 1 divided by how many. And this step I should start adding so many times to get 1. So for in E in range how many plus 1, and output params equal to empty list. So all params. So I'm creating now an empty list for the parameters which I will be creating. Append step multiply by I. And just return it. Return all params. So let's see if it will be working. So I would like to put it as the output. So this will go into the to the comment, and I will use my mic parameter. Make parameter. Is it the correct name? I will just copy it to be sure. Make parameter from 4. We have some issue. Let's see. Yeah. So the step 1 divided by how many? How many is an integer. So if I would like to make it as the float, then probably this will solve, but then I will have an issue, or maybe no, there will not be an issue. Step I float from I. Let's try. And then invalid string, how many plus 1. Let's use now how many. Okay, now I get that I didn't add the colon here, and I start to change the conversing the data types, since it could be also a problem, but I think anyway the Python script will manage with it. I sometimes am still astonished how forgiving it's Python. I will see if I will not have to add this floats. Yeah. So he automatically changed the integer into be a float. And this, in other programming languages, you can have a problem with that, but this definitely was the lack of the colon at the end which caused the problem. But anyway, the code is up and running. So from I to 1, I have if I'm putting 4, but then the make parameter is 4. So how many? Probably I should use then, because I would like to have 4 elements. I see he's giving 5. So what I will do, I will just do it like this, and this should work probably. Yeah. So if I have 4, if I want to have 4, then I would like to have 4 of them. Okay, so we have the make parameter 4, and then we can start to create the points in the creating surface points. So yeah, let's try to make it. So params x equal to make parameter. I'll take it here. Control X, Control V. Make parameter not 4, but in 3. And the same I want to have for the y direction. So make params in the y direction, not 3 but 4 this time. And then how I can create the points on the surface you already know. So I would like to name something like a nodes, and then those nodes will be collecting all of the points on my geometry. So nodes, I need some loop for px in params x, for py in params y. Let's see, spt surface, and then nodes append spt. So let's take a look at what will happen if I will give him here a px and py. And let's see what we have here. I would like to show those nodes, of course. So I have the nodes 12. up and running. But again, if you take a look on the outputs, okay, the first list is the points, then we have a surface, curves. So this one, it's one long list of the points. So I would like to have it again in the format, which is allowing me to create the some lines in between or polylines, which I can later explode. But take a look how I use the definition. Although I just create one definition, then I can just use it twice. So I already save some time of mine to create a quite useful function. Now, what else I would like to do? I would like to create a list of the points in the specific data format. We already have been practicing just on the previous session. So let's try to do it in the next part of this session. Okay, so we have the nodes, but they are not exactly correctly placed in the format which I would like to have, because I would like them to be in the list, which is, as you already know, allowing me to very quickly create polycurves and then, for example, explode those polycurves. So let's try to do it. But since I very often, I would like to have some operation like the definition, which is flipping, which is transposing the matrix. Maybe it is possible to make it with the definition. So let's try to make it with the definition. But before we, of course, we have to create a list in a list. So nodes X, for example. And then very simple thing, append nodes X. So let's save and run. Let's see how does it the data format looks now. I am searching for the last one, and I see that I can, for example, now click the first one, the first list, and I see all of the points in one specific row. Okay, so what we want to do, we want to um, create a definition for transposing or flipping matrix. So I will call it flip list. I don't have to, or the flip list, the input will be the list. So some list, I will call it. And then let's do it. So what I want to have, it's also a list. I will call it maybe a new list or flipped list. Flipped list. It's the empty list. So how to do it? Then first let's try to read the size of this list. So size will be the length of some list, and then the for loop. It's going first for I in range size, then flipped list X, for example, equal to empty for J in a range, and then how to get the size in the second one. Here it's a small small thing. I can flip only those ones which are rectangular type of the list, so they have exactly the same amount of the elements in every smaller list. So size y, for example, let's call it like this. Its length from some list 0, because I know that every list in the small list it's the same size, but I have to remember this. So in fact I should make some comment. This is definition for rectangular lists. We could make some verification like with if statement if this number is exactly the same in every row, but let's just right now be it's not in this course about like heavy coding and creating super safe interface. It's more about for you to get the basic of creating the code. So right now we just have to remember that the list which you are putting here have two layers, and the list which are in the outer list it's exactly the same in every place. So flipped list, it's empty. Then here we will have size y. So maybe to make it consistent, I will just type like size x and size y. And what we want to have here, it's flipped list x equal to some list. And then after getting outside of here, we are saying flipped list. Sorry, I make of course some basic. It's not a QL, it's append. And of course, it's not flipped list z, but x. Flipped list append flipped list x. And then there's a question what we should put here. We already tested, so j and I should be here, and the thing which we want to, oh, sorry, I have to check it. No, okay, then I just have to type return flipped list. Okay, I think it should be working. Probably, maybe I make a mistake here, but we will fix it in a second. There is no need of apostrophe here. Let's see if I make. Okay, now it should be fine. Flipped list, some list. So now I would like to have also flipped nodes equal to flip list nodes. Some small mistake. Probably J should be here and the I here. So let's see. No, the problem was not I and J. The problem was that somehow I put here a D. Sorry for that. So it should be length, some list. Here should be IJ. And I think, let's see, this is flipped list. Save and run. I think it will work fine. So now I have nodes and flipped nodes. I will just add it also here, flip nodes. So let's take a look in this. So number 4 are, I will make a little bit less of the elements, like 3 by 2. So I have 2, and the 4 lists, it's 2. So let's see. I think we have one small mistake here. So yeah, instead of the size x, we should have the size y, and the j and I should be here. So let's see. So I think I put here a size x on the beginning and size y here, and the J and I will be working now. So then if I will go, I have 2 lists per 3 elements, and here it's 3 lists per 2 elements. So finally the flip list it's working. Okay, yeah, then in the next, let's just to see if this is working correct. Yeah, but it seems like it's working fine now. So let's try to create the lines in between. Okay, so in this part we will try to create beams, and in one and in second direction. So first let's try to create them in one direction, creating polyline maybe, or let's take lines. So you remember that when I was talking that, and we are also after the robot task, so we know how Autodesk Robot wants to have the elements being done. It should be the lines in between the nodes. So let's try to do it also like this here. But first let's do the polycurve. So I will do like this for um, EX in nodes range length nodes. So then I can say that polyline nodes are equal to nodes from IX. And then what I want to do, I want to add the, I want to create a poly curve. So poly curve by points, and I will type PL nodes. So if I have it like this, polycurve by points, then I can say PC, which will be the polycurve. It's equal to those ones. And then I need to have like container for it. PCS append PC. So as you can see here, I'm creating first, I'm taking the whole list of the nodes. Then I'm saying that this list of the nodes should be my polycurve. And then I'm adding this polycurve into my list of polycurves. So let's try to add it here and see if it's running. Then it's running. Then you can imagine right now that this one could be a function because again, I need to do it twice. So for one direction and the second direction, there is no need, or I can just copy it, Control C. And here I can just create another function, which I will call create a list of polycurves from list in a list of points. Definition, make list of polycurves. The input should be the nodes. So I will say like this, Control V. Then this one I can just move. And then I can return. What I can return is of course the PCS. So let's just see. The nodes I named the same naming, so the nodes will come here. He will take the nodes, PL nodes, it's this one here. So should be working. Let's try. I'll just copy the name, make polycurves. And here PCS, let's make poly curve. So I will say poly curves in X, or sorry, in one direction, in one. I will call it D1. Of course, this one should go here. Let's see. Something. Make poly curves, of course, from nodes. I have them. And then if I will just copy it for the D2, and I will use the flipped nodes, I should have also in the second direction. So I will just take them out, D2, and I have them. So now if I'm introducing more of it, I generally see that I have a grid show on my structure. So then we make them, but you remember I would like to also have them as the list of the lines, not just as the polycurve. So how I can make the polycurves to be aligned. Let's take a look for the code block for a second, and if I will typing polycurve dot, then I have something like curves. Let's see. So then he should give me a list of the curves if I will give him a polycurve. Let's try to do it. So let's see if it will be working. So lines D1 equal to poly curves. So D1 dot curves. Let's see, but here I need to have one element, and let's see if it will work. Something it didn't turn yellow, so maybe it's working. I will just type lines D1, and the rest I will put into the comment right now. And here we have a problem. So lines D1 he didn't want to make, cannot convert object to target type. Okay, let it be like this. So what I want to check, it's polycurve, polycurve dot. I'll just see if there is something cool. No, that should be fine. Okay, I will go for curves, and then I will type polycurve D1 0. Control C, Control V. Let's see if this will work. So here I have a list of lines. So this way of calling the method polycurve.curves worked, but it was working only first. So for the first one, if I will take the 1 and 2 and 3 and so on, it will be working. So now what I want to do, I want to create another loop, which will be generally putting my lines already as the list of lines, not polycurves. So should we make a definition, or should we just make it in the simple form here as the one loop? Maybe let's make it this time just a loop to do it. So for PC1 in polycurves D1, then here I want to have PC1. I'm just checking if I didn't use PC1 before, but I don't think so. Lines D1, I want to have like lines D1 as the empty one, and then I want to just add it. So lines D1 dot append polycurve BC1. It will work. We will see. Okay, it's working. All the elements are flattened, or no, they are also in the correct form. So here it's since the list of polycurves it's already in there. So if I would choose one list, it's the one single list. So right now I would just create the second for the second dimension. So PC2, 2, 2. And then if I have lines D1, I will also add those lines into my elements. So instead of using polycurves D1, I will just lines D1. Okay, seems like it is working. So what we want to do next is we would like to create some kind of the diagonals. But to create the diagonals, we need to organize the data even more. So I will do it in the separate part. So creating a grid shell diagonals. Okay, we will be trying to make the bracing now. There is a lot of ways how to make the bracing in those kind of the structure, but let's say that first we will triangulize almost every cell in my structure. So I would like to, from the rectangular shape of the grid shell, have the bracing everywhere. So triangles everywhere. Let's just maybe make a next input, which will be the type of the structure, and this type I would like to have like the a text as the input. So, for example, type A will be the, the grid shell with rectangular um, rectangular parse, and the type B will be with the, so let's make a type B as the second option when I would like to have the diagonals there. So let's write a statement. If input 5 will be equal to type B colon then something. So we need to add the bracing. Or we just need to create all of the beams. So I will just type beams. And those beams will be like this. Since I always want to have, if beams append lines D1, beams append lines D2. If in, so maybe instead of typing in 5 every time, I will just type, I will make grid shell type GST equal to in 5. So GST equal to type B, and let's make here type A. Later we can think about other types. So of course the beams should go there, but also I would like to create the bars. So instead of lines D1, D2, I will put here beams. And maybe right now let's see if it's working. So I will put like this. Save and run. Let's see what I did wrong. Um, 110. Yeah, so the issue which I make it's not working is because I should also for now on comment this type B, because instead then the out is going into the elif. So if I will click like this, I will see my elements. So also like, okay, let's make it like this, save and run. So and let's maybe make it here beams hashtag. So if I have a type A, I have in both directions. If I'm connecting to type B, I will have in one direction. But the deal is to add the bracing. So how we can create the bracing? Let's try to work on the nodes and create a definition which will be creating the bracing. So another method to create bracing everywhere. So this time definition bracing, make bracing. Here I want to have nodes. So remember the nodes are a list in a list. So each list is having the series of the points in one direction. So it should be enough to create the bracing. But the deal is, yeah, how to explain it? Maybe we can try to make a snip nodes. New. And let's try with this one. So what I want to do, I want to, in general, create a bar from this node to this node, and from this node to this node, and from this node to this node, and also from this node to this node. In general, I want to have a bracing everywhere. But the problem or the thing is that if I will just connect from this row of points, the points to this one, it will just create the lines. So I would like to connect this element to the +1 element here. Also the problem, if I would just +1, then it will go outside of the bracing. So I also have to limit it. So I have the next row of the points which I will be using have to be a little bit shorter. So let's try to make it now. Okay, so when we want to create this make bracing, we first have to, as I was saying, that we have to control the number of the elements in each specific row. So let's try to get it, like number D1, which will be the number of elements in one of the sections. So length nodes, and then number D2 equal to length nodes from 0. Again, I'm getting back to this, that we have to control that this algorithm is working only for the rectangular shape of the points, grid of points. And now what we can do, it's we can create our algorithm. So for E1 in range number D1, So here we are going into the number of rows of the points, and now we have to connect them somehow with each other. So for E2 in range number D2, and now the diagonals. So I will make diagonals empty list, which will be holding the list of the lines. And let's try to make it. So for E2 in range number T2, point 1, it's nodes. From E1. And then we are going into specific, so if I will type E2 and the point 2 will be nodes E1 plus 1 E2, then they will be connected exactly the same point. So I will have just the beams which I already have, but I would like to have a diagonal. So I should put here plus 1. To connect it. But then I will have a problem because I will not be able to so I will get out of the last because we have like 10 points and plus 1 it will be 11. So I have to subtract minus 1 here. And maybe this will work, I'm not sure. Diagonal equal to line by start point, end point, parenthesis, inside parenthesis P1, P2 should make the stuff. And then I just need to say diagonals, append diagonal. What we want to return? Yes, you have right. We want to return diagonals. Okay, make bracing nodes. Let's try. So if beams, else if type 2. So with bracing beams, append, make bracing diagonals. Some mistake expected, but hopefully, so make bracing diagonals, line 121 is not defined. Of course, this is nodes, sorry. So now it still don't work, but we have a line 45. So we get here nodes P2, nodes E1 plus 1 and E2 plus 1. Of course, I should also subtract this one by minus 1 because then it will not work. But finally, after those small changes, number D1 minus 1, number D2 minus 1, then we have the algorithm up and running. So the code, as you can see, I can choose the specific type of the structure, type I, type B. Still, let's use the type B and see if it's it's referencing to the number of the changes which are specifying, and then still, if I would like to make it control also the height of the structure, then we have it. Okay, if you see here, I didn't use any variable, I just assigned the definition directly. There is no rule that you have to first create some kind of the variable like bracing equal to make bracing nodes. It's depending by you if you prefer to do it like this or in another way. Generally, this bracing if we are calling it, then we are running it. So the processing time will be duplicating if we would like to do it in twice, for example. So a little bit better is to put the processing of the elements which have to be, or let's start this discussion over. Not over, but again. Let's start it again. So if I would, because I could make something like this, bracing, Control X, Control V, and then what he will do that when he I was just creating bracing lines. So he is creating the bracing every time we are running this algorithm. So even if he's doing type A, he's also calculating them. But and if he's doing type B, he's just adding those bracing into the system. But when I am moving this one into the else if statement, sorry, then what he is actually doing, then he's creating the bracing only if the type B is activated. So if you don't want to make super long codes for a specific types, then you should rather run those definitions methods only when you are using them, because then we are not making the algorithm unnecessarily slow. Um, think also about this aspect when you are creating the software architecture. Although this is very primitive architecture, generally already here you can make some mistakes to and slower down the algorithms. So especially if you are thinking about creating something with the if condition and different types, then you will it's definitely worth first figuring out where this function should be activated, because definitely this is a better position for this, because the type B will if it will not be activated, then we are saving the time of the calculation. Okay, so we have it, but I would like to have also type C, in which only in the first and the last row we are having the bracing. So not all over the brace, but only on the first and the last um, row of the elements. So let's try to make it. So how to make it? I will just copy this bracing everywhere and create bracing in the first uh, and last row. Okay, so we are going here, number D1, length nodes, number D2, length nodes 0. This can stay, although probably the diagonals which we need. So make bracing in last first. I will call this version of the algorithm. Diagonals are staying the same. This yeah, we'll see if we need it or not. But generally, what we need to create definitely one for loop, but not necessarily this one. Of course, we could make a statement if I1 it's equal to 0, then uh, do this one. Control C, Control V. And then else if, or we can just use just to learn you. if E1 is equal to 0, okay, obviously not the OR, it's just the keyword OR. And here we have one mistake. I'm taking number D1 minus not 3, but 2. Then if we will go at the end, I need to add here type C, then bracing, make bracing last first from the nodes, and then I'm appending those elements. If I will click save and run, he should work. Let's see, type B, A, and C. So we see that the bracing is only on the first and the last. Let's take a look again on this bracing. So here I1 equal to 0 or I1 equal to the last one minus 2 to be here, and then he's creating the list of the elements. So we create another variance of it, and yeah, maybe one more part about the solids and operating on the solid objects, and we are done with this week coding. Okay, give me a second because I was just recording without having the headphones on. So I have to restart it. And the thing is, I have my Python script, which I called creating grid shell. So I can rename it creating grid shell. And now I would like to create another code, which will be creating columns here in the bottom. So I need to create some kind of the plane on which we will be projecting points, and we will be declared that this is the position of my legs. So let's create another Python script. This time I will call him creating columns. Okay, one of the inputs will be my Python script, and the second will be the position of the XY plane. So I will just give him. Oh, sorry, I will just type, for example, minus 3.5. So this will be support level. I will accept it. I will go here, and then we can start coding. Hopefully nothing wrong I did. Okay, so what I need, definitely I need a list of points. So if I could just take, or maybe first I have to see if in my Python script, the first one, oh, now I have just beams. So I would like to have all of them. And I will be referencing to the 0, 1, 2, third one. So I will take it here. And now in the in 3, or let's do it like this. Nodes, it's equal to in from third. So let's see if it's true. I will type nodes. Line 11, it's not working. 9, of course, it's not working because it should be line 0, 3. Let's see now. I will just turn off the preview of this one, so hide geometry preview, and I just have the nodes, so this one is up and working. So finally I have what I wanted to have, because I don't need any bars and beams right now. I just want to have the nodes. What I also would like to have in this algorithm, or let's make it step by step. First, let's create a plane. So plane by line and point by origin and normal. This sounds like good for me. I need to create a point and the normal. The normal will be vertical, so it will not be a problem, but the point, let's give it like origin, I will call it, and then the normal. Let's try to get it out. PL equal to my plane. Let's put it here. Origin. It should be a point by. I would just take the nodes. Sorry. Nodes 0, 0. So should work, and the normal, it's nothing else than the vector. So vector by coordinates 0, 0, 1. So let's try. And this is my point. And then this is a support level. So my I don't want to have a nodes. I want to rather have a point by coordinates 0, 0. And then I would like to have my in 1. Let's try. Okay, it moved down by 3.5 meter. So this should be up and running. Okay, how to project the point? Let's see. Point, project, and then we have something. I will use the code block for a second. Project. He's waiting for the base geometry and the direction. So what he really need is that projected point, or let's make it like this, projected PR nodes, empty list for E1 or N1, so the nodes in the first layer of the elements in nodes or range length nodes for N2 in range nodes length. So N1 and N2. So in this case, if I will take node, it's equal to nodes N1 and 2. What else? Projected node. It's equal to point project. Then he need a node, and then he need a vector by coordinates 0, 0, -1. And then he need a projected plane. Point base geometry is the second. So sorry, after the node, we should give him PL and the vector by coordinates. If I click save and run, he has a problem in the line 22, but it's fine because I didn't remember to close the. Let's make it. It should be like this. PR now it's projected, save and run. Now it's working, and PR nodes append PR nodes. PR nodes are going outside, and it seems this is working. So they are a little bit below the elements, so it's fine. But then what I wanted to do, I didn't want to make all of them. I just want to have them in the first and the last row. So again, the same system. If when we were using the version type C of the grid shell, I would just put an if statement. If n1 it's equal to 0, or n1 it's equal to length nodes 0. Then do this. If n1, of course, it's not it's n2. If n2 is equal to 0, let's see what he has a problem with. Yeah, I forget the brackets. So I have the first, but we already see that there should be like n1 equal to 0 and n1 equal to length nodes, because I did it in the wrong direction. So I have the first one minus 1. So I have both beginning and the end now, all of the elements. And I would like to have them maybe in the separate list. So I would like to create a list which is the first row. Let it be. Then if this one, I'll just copy it. I will put elif. This I don't need. Last row. First row. Append. Last row. It's here. And then sorry. This first row and last row we will take here. And we can say that projected nodes, it's first row, last row. Let's take a look, and as we can see, they are in the correct format, meaning that they are a list in the list. Although I think, let's see, yeah, if I'm clicking here, yeah, I have it. So it will be a little bit easier if probably I will take the first row and the last row projected to the specific level. So if we see that they are in this form, then the solution how to make it in the one, it's to, for example, use extend, because then we will not be restarting the algorithm, and then I will have the first row here and the second row there. Okay, so we finally get the elements in the specific data format, so we can operate on them now. I would like to connect them with the specific, or I would like to create a columns first. So let's try to make it. So first row columns should be an easy peasy now. If I will just create it like this, and last. Okay, so we have first row column, last row column, and we will try to see what's happening here. And generally, I see that we have one issue here, the append and extend thing. That if I was clicking extend, yeah, it was adding, but generally the projection, when I have to show you something. If I have like a point dot project, and then opening, you see that he's giving me back not a single geometry, but a list of geometry. So I was also a little bit, I have the strange feeling that maybe extend it's not the best option, but then I realized that the PR node, it's not exactly just a single node, but is a node inside the list. So in fact, we could do like this, that we are taking and then using append. And maybe this will be a little bit better option to do. So the effect will be completely the same. Uh, but now the peer node, it will be just a single node. So if I will type line by start point, end point, I should be able to make from peer node, so from the bottom till the node, a column. So if I will type column equal to line, this will be uh, giving me a column, and then first row column dot append column, and the last row column dot append as just a column. And the last thing what we have to do, we just have to create columns equal to first row column, comma, last row column. So let's give it out. So brackets or parentheses, whatever, pure nodes, columns. Okay, so we have the columns here. Now, those nodes and columns are working quite well. I would like to also connect one more column. I would like to create not only straight elements, but also the elements from the bottom till the next row of the points. So it should be possible to do it in the exact the same way. So if I will type, for example, column and copy it and type column 1, then the node, I have to create node 1 then. Let's take a look. So column 1, and then first row column will also have column 1. So let's see if I'm able to take them out. Yeah, node 1, and I have it. And the same I will do with the node 1 here, but this time, since it's the last one, I will type -1. So this one, the column 1, and this one. Okay, so as you can see, the more of them I will have, the closer it will come, and it will create those elements. Okay, now last thing before we will go, it's to create some algorithm which will be checking which elements are bigger than something, and it will be creating some visual effects on it. So, but let's do it in the next part. Okay, so I would like to right now create another algorithm which will be checking my structure, and it will try to figure out which are elements in the specific dimensions and try to maybe color them in a specific way. So what I will do now, I just need one single list of all of the elements. So to do that, let's try to maybe make it a little bit bigger. I am still working in the Python script creating columns, and I will maybe make two inputs, or maybe one input, and here I will be giving like a list of two values. Like I would like to say which one of the elements are between 2 to 4, the in 2. And then the outputs. Right now I would like not to have only the columns but also the whole beams in the grid shell. So I think the beams are, let's take a look, 0, 1, in the fifth. So beams equal to in 0, 5th, and let's see, columns, beams. Okay, so I have it. I have my columns and the beams, and right now I would like to make one single long list. So you know that those beams are a little bit a list in the list, and also we have the columns which we would like to add to it. So if we would like to flatten it, we preferably would write some kind of the definition to do it. And I would like to introduce some, by doing this function to flatten the list. I would like to create a recursive formula. So if I will call it flatten and then list, then flatten list will be just this one, in which we'll be holding the flatten element. So for item, for whenever argument in the list, I would like to make the if statement. If this element is just one single element, then it should be added. But if it is a list, it should again flatten this list. So it will be self-calling function. So the function will call itself to make it. In this case, we can if is instance. So it is checking if this is the single element list flat list extend flatten, and here we are calling item. So what we are seeing here, that we are calling the function which we are creating, and this phenomena it's calling recursive formula. So we are calling the function which we are using. It's a little bit sometimes can be dangerous because we can call it till infinity, and the software will not finish their work. But if we know what we are doing, it's kind of the okay. So if it is not a list, then we will just add the element. So flatten list, append item. The only new thing here is instance. It's checking if this is one single element in the list. And then I think it's all. We just have to return. We of course are returning the flatten list. And let's see, beam flatten. So now I didn't click yet the it's this one. It is a list in the list. If I will click run, it should, of course, some mistake. Line 12. Let's take a look. Argument 2 must be a type or tuple of types. Okay, let's take a look. Okay, I found the bug and it's quite of the basic thing. I use the keyword list as the name of it, so I have to change it to something different. This is list or maybe input list, something like this, because what we are checking here is if the item is a list. So list is a forbidden word. If I will do it like this, then you see that I have one long one long function. So if I would like to have also the columns inside my beams, I could, for example, do like this. Beams equal to in 05, then let's make it elements, columns, beams, and of course the one which I will just flatten will not be in 05 but elements. Let's see where is the mistake. Beams, columns, line 59, elements. We are missing the assigning. Okay, it's quite a long code, so I'm also getting tired, but it's just one last thing which I want to show you. So this is a recursive formula. Interesting concept. We are calling the definition in the definition which we are creating. So the function in function. But what I would like to do next is generally to sort the elements. If we will finish the sorting, we finish this task. The last thing what I want to show you, it's how to make maybe colors then. CLE, add reference. Sorry, what I am typing. Add reference, and here should be the DSC or DS core nodes. So we are calling the core nodes library, and from it, from DSC DS core nodes, import everything. Import or just color. So the color, it's hidden here. And then if we have all elements into, one thing, elements, columns and beams, and the elements should be as elements. So the only thing which I want to give out are those elements. So let's take a look, or flatten elements. Let's take a look. Line 7. Where is the mistake? From DSC core nodes, I have to. Oh, sorry. DS core. It's the name of the library. So DS core was the issue, not the thing here. But anyway, flatten elements. It sounds better. We don't need to have it here. So now we see that this one long list of all of the elements. So now the only thing is to make a sorting algorithm. So I would like to have a smaller than 2 in between and the bigger. So smaller middle, bigger. Now condition 1, it's equal to in to 0, so this will be my first, and condition 2, it's in to 1. Nice. So now we just make to have a loop for E. Okay, so yeah, for E in flatten elements, so we'll go through each one of them and we will just sort them if they are bigger or smaller. So F element, if condition 1, so first we have to check the length of this element. So to check the length, we can use the curve.length. So let's use the code block to see how it is working. Curve.length should give us something, so we can try to see. So let's see lengths, LGS, sorry, append E dot length. Let's see if it will give us the length. So LGS, save and return. I have some issue here. So append E length, he was not able to read automatically, but maybe I make the mistake in the line. No, 71 for the F elements. Okay. Now we have the length. So L, I can type E length and check the condition. So if L is smaller than condition 1, then definitely smaller. Append E. Then L if L is bigger than condition 1 and L is smaller than the condition 2, then middle size append E. And the last option, I can type just else, bigger dot append E. Okay, but in this scenario, we will have them already put it into correct elements. So let's try smaller, middle, bigger. Let's see, save and run. So you can see that 2 didn't work so well. Now I have them, yeah, in 3 lists of objects. So if I will just create a simple code block with A0, semicolon, A1, and A2, then we can see those objects here. Those are the elements from the smallest. Those are the biggest elements, and we have some number 3 with those elements here. Okay, so let's see how many in total. Okay, then these conditions, I assume it's working. Just last thing, here we have smaller, bigger, and also Yeah, and then it's fine because the bigger are equal to condition 2 or bigger. But we want to also add the colors. So I want to create a color for the specific value. So I will type color equal to color by RGB. And then what he's waiting for, it's like 255, 255, 00. I don't know how familiar you are with the colors, but generally RGB colors are working from 25 to 0. So this will be, for example, a red color. If I would like to have a white, it should be zeros everywhere or 255 everywhere to have it all in the different color. So for colors, let's make exactly the same list. So smaller, bigger. I will just type C at the end. So this will be colors, and smaller C will be added dot append, and here I will add my color by RGB, and the same I will do for the middle, and the same for the bigger. So now I would like to have them also outside here. So let's say that I would put those elements in one list, and the second one I will put colors here. So with the C will be colors. So now this A0, A1 and A2, since those is, I will just save and run. This will not work because there is no A2. It's rather like this. And then what I can do is, for example, make here B0, B1, B2. And let's take a look. If those are just the lines, then if I will connect similar thing to here, I should see the colors. So there is something which is called display. Let's see where it is. Display by geometry color. And if I will connect those together, I should have the specific display. I will just turn off the preview of everything, and I will just leave this geometry by color. So those are the smallest one. Those are the middle one. And those are the longest one. But the deal is that they have exactly the same color. So let's try to fix this one. I will say that if they are middle, I would like to give them this kind of the color. So 250 and maybe 50 for the longest here. This I don't need. I can just put into the comment. This is just a case how you can create a color. So now I think the 50 here, sorry, it's for the transparency probably. So I will make maybe 55 here. So we should have the elements. So those are the third one. This is the middle. I don't remember what was the blue color, but let's make it 50, 50, 50. Okay. Then I start to see it. Yeah, just give me a second. I just want to see 200. much better. So we have green, yellow, and the red. The red are the shortest, and these two are the rest. Okay, it's enough for today. This is the end, and generally this is also the. I'll just save and take a look on the code. So it's, as you can see, when I am changing now the position, number of the divisions, I can control how many elements have what kind of the shape. I can also control the ratio of the shapes which I'm interested in. I can decide how many elements I have to find, for example, the one in the shape which I would prefer to have. So I hope it was an interesting task for all of you, and generally this is exactly what you have to do for the assignment. I hope it will be possible to you to do. So I will just make some print screens and you will have the assignment.